Well, hi, good morning. Thanks so much for joining me here in my shop. I'm going to go the next step with this radio, which is essentially completing the radio receiver side of this, completing its alignment. So when I'm going to back up a little bit, I'm going to repeat the first alignment step. I did the IF alignment using a single frequency of 455 kilohertz. Now I'm going to try it with a sweep, which sometimes I struggle to make this work, but other times it worked quite well. So I think just for fun and pleasure, I'm going to set up a sweep through the IF of this radio, and we'll look at it on the scope and see what kind of shape we get. Should be just fine. I have no reason to think there's anything at all wrong with this. Okay, first thing we want to do is set this to sweep properly. So we'll set the start frequency at, let's say, 20 kilohertz below 455. So that would be 435. So I'll set this sweeping from 435. Okay, and we want it to sweep up 20 kilohertz above, so that'll put 455 right in the middle of the sweep. So 455 and 20 is 475. 475. I don't know if you can read the numbers on my counter there, but so the idea of this is 455 should sit right in the middle on my scope if I balance the display properly. And that'll indicate where 455 is on here. Of course, there's no calibration on my scope for that. Guess I need a lead here. We're going to measure the. We'll measure at the same place we're picking up the ADC voltage. Basically, diode load. And why they use the phrase load, I haven't quite clued into yet. Why they call that particular spot the diode load. I guess maybe there's, you have a diode, you have a resistor that its rectified current is flowing through. Maybe that's the load on the diode. So when you check with this, you're really checking across that resistor. So maybe that's why they call it diode load. So that's going to be down here. And the other one will clip on ground here. And we'll set the sweep so the scope sweep is no longer internal, it's being driven by the sweep output here. There's no sweep output at the moment, it's not sweeping, so you see a dot. And if necessary, I'll put a close-up camera in there. I'll certainly do this at this point. Okay. Just trying to see my own TV screen. That's not too bad. Next thing now is to get this playing here. There. It's plugged in now. Power on the dim lights. Double checking here. Unnecessary clip lead out. Everything else looks good. Okay, on we go. Dim lights on. We'll start the sweeping now. I'll center it. I should put 455 in the middle. You can't be absolutely sure of that, even though I've set it up to be that way. Turn the volume up here so we can hear what we're seeing. I saw a little bit of noise there briefly, and now it's gone. Put full power on here. So that was extremely interesting what just happened there. Oh, wait a minute, it's coming back. So what I saw happen there, what I heard happen there, I didn't see it on the scope. When I applied full power, so I raised the input from like 90 volts to 115 volts, I heard the radio reception get stronger briefly and then fade out, and then come back a little bit. as if there was some range of voltages there where this receiver is working better. So is that really the case? I don't know. It's just something I noticed. I'm just drawing it to your attention too. You know, we can re-demonstrate this if I just cut back to I'll just put the dim lights on again, and we'll see if this thing doesn't, as it quiets down, if it doesn't get louder. Get louder while it quiets down. No, it just got quieter all the way. I'll just turn it up here. Well, I didn't notice the same effect at all, so just ignore whatever it was. Just ignore me. Hey, I ignore me a lot. Okay. So we want to get something. See how this has drifted off a little bit here. There we go. Now, why aren't we seeing this? We should be seeing this. We're sweeping through. Oh, not enough signal level here at all. So we should start hearing. Actually, I'll slow this down a little bit. Here, we should hear this. I don't hear a thing. This is wide open now. Hey, how come the set went quiet there? I'm not doing anything. Squelch. I fiddle with the squelch here. Wow. Wow, the squelch becomes active right away. Like, that's the limit. Wow. Okay, we're still not seeing any kind of sweep through there. Waiting on. Here we go. Let me turn this down again. I see what I've done here. It is down. Yeah, okay, there we are. So what happened was I did not actually have the output of this connected to the radio. The radio was hooked up to the antenna. I had a switch wrong. So now we're seeing the IF response to this slow sweep going through it. We're going to speed it up here. Turn down the volume. I don't really need to hear that. So I'm flummoxed already. Why all these little peaks here? It's not right. It's really not what I was expecting to see there. What's going on? Hey, they're fading away. The sound's fading away too. What's going on there? I'm not doing anything. So it's two things now I really can't account for. One is the series of little dips along here. And the fact that it faded out there for a minute. Okay. So this will tend to display roughly the center of the sweep. Exactly why it does that, I don't know. Like it's averaging it somehow. I don't know how it's arriving at that, but it is 453. So this reassures me that this is sweeping through 455 kilohertz. It's fading out again. I have a lot of faith in this instrument not fading out. Something's going on here. Just give it some more time. So it's a long shot, but it could be some problem in the wiring that I've got arranged here. So I'm going to wiggle the wires around and see if the radio signal doesn't jump up. Speak of the devil. I think I already hit it. It disappeared entirely. What I didn't exactly do much. having a lot of trouble with this connection here. This one connection here is giving me a lot of trouble. Maybe into the back of the radio. These are brand new cables, essentially. You know what? One of them isn't. This one here is not a brand new cable. Okay, so I'm going to take this one cable out of here because this one may be questionable. We can't have the signal fading up and down because I've got bad cables. We cannot have that, so I think I can get away with a little change over here. I bought these little cables off of the internet, these little guys. I thought they were twice as, or 3 times as long. They are very short. Okay, we're going to maintain this connector here. Loose on the back of the radio. There we go. Nothing wonky now. Much higher signal level here. Turn down the volume there a little bit. Still really, really not at all what I expected. Why? Oh my gosh. What I'm expecting is just one dip like that. Not 5. 5 dips. 5. What is going on here? So I'm scanning through the IF and it's repeatedly showing. It's repeatedly showing. You know, I don't know how to even finish the sentence. Let me just change to a different crystal and see what happens here. Okay, so there's nothing. Yeah, there's no crystal. No crystal. This is channel 5. Nothing. 13 and 15. 13, 15, 13. 15. So this is moving a touch. Wow, what am I doing here? That is so wrong. So I am feeding the sweep signal in through the antenna, which is not really the appropriate way. So I'm going to change the feed point from ramming the signal in through the antenna to feeding it into a tube grid just ahead of the IF, which is really the proper way to do it, in fact. So let me get that set up and we'll see if we can get rid of these, get rid of that thing on my scope. Okay, let's just see if we can't pick off V2. That's a 12 BE6. Something very interesting about the tube lineup in this radio. It actually has 2 tube lineups. One for 12 volt 120 volt operation and one for 6 volt 120 volt operation. You actually pop out 12 volt tubes like a 12 BE6, you pop in a 6 BE6. In some other cases you pop out a 12 something tube and you pop in a different 6 something tube. And so you can, with a different tube set, this thing becomes capable of running on 6 volts. There were cars that had 6 volt battery systems in them. So the clever engineers here figured out how to do that, and when you study the schematic you can see the way in which they've arranged the heater circuits. Now the radio just went quiet suddenly and I don't like that. Now either I bumped something just now, let's wiggle a few things here. Or extra lead here out. Okay, it's coming back a little bit. Maybe a wonky volume control? No. Squelch again? My gosh, the squelch is active up here. Something not right with the squelch. You should be able to turn it quite a distance before you get squelching action. And that could be because I really don't have a signal coming in here. Let me flip this onto the antenna. Okay, now we're on the antenna. You see the AVC voltage come up over here. That's better. That's more normal. So I guess it's just the signal level is so low that even with the squelch set down here, it's activating it. The squelch, I've switched it back to the signal generator. The squelch in here is not a real sharp cutoff. It's kind of a, it has kind of a draggy. What kind of a word is that? That's the word you use when you're only applying about a third of your brain to what you're saying. And the other 2/3 are just taking time off. Okay, let's take a look in this radio at vacuum tube number 2. Vacuum tube number 2. Can you see it in there? I can see it. Vacuum tube 2 is right here. And I want to get onto pin 1 with a 0.01 capacitor. Here's my 0.01 capacitor here. But look, my fingers be touching that clip. I don't think I want to do that. So pin 1, easily accessible. This capacitor right here is on pin 1. I can just get on the lead, you know, but if I clip this clip on the lead, it's just going to rotate around. We'll have a short circuit in there before we know it. That's not so good. You want to really clip it onto a terminal. The only way is to get right in there. Oh my gosh, there's just a ton of stuff in the way too. Okay, different clip lead here. I don't like extending the clip leads, but I need to use a very particular clip lead, which, where is it? Here it is. Okay, so this one has, you know, this kind of grab. Problem is I'm just making more and more clip lead wire here, but let's do this. Okay, I'm gonna clip the, I can't see this, I'm just clipping the capacitor onto the end of this lead. Okay, now I'm gonna put this down. I'm gonna clip it right onto the signal generator output, but the ground is not connected yet. That means this may generate quite a bit of noise. Let me hook this up. The output of the signal generator is nil. Okay, I'll put this on. Shouldn't be any surprises here. So I'm trying to see what I'm doing. I'm going to go right here. Okay, so it's just quieted down the radio. I'll turn the volume up there. There you can hear the signal generator going. Good. Show. Now what do we got on the scope? Just up elevator here. Look upon the scope. It's a little hard to see in the camera. It has a dip right there. One single dip. Isn't that interesting? So, see, if you do things right, things go right. Okay, so that's a very low level signal coming in, coming onto this. In fact, I can't even get it any lower. Isn't that something? So I'm gonna turn it up a bit and get a little bit of a bigger dip there. Just looking for any variation in a frequency shift of any sort. Okay, I'll turn down the sound so we're not listening to this so much. Well, had I had this, if I have this set up correctly, this 455 peak should be right on this line. So I'm going to double check the way I've set this up, because the peak is over here. It's not at 455. Or has this thing drifted? So first we'll check the start frequency. 431. I was really targeting 435. So it's drifted a little bit. 435. Okay, I get this as accurately as I can. That's pretty close there. And then the stop frequency, the 475, and it's also drifted downwards. That explains maybe why the center point was off to the side. 475, that's pretty good. Sweep. Now we see we're really quite close to the center, but not dead on. But you know what? This is not in the center anymore. So I'm looking at the ends of the display and getting them balanced. And when I do, this is just about dead center. How much more accurate can you want it? Now we'll look at the shape of this. I'll increase the amplitude here. Get you a little bit of a better seat to see it. We're getting a nice smooth curve here. A little more amplitude, please. A little less volume. As I turned it up, it seemed to move over. Is that right? No, it's not right. Now, I think something that might be interesting to watch is the AVC voltage level and what's happening with the signal at the same time as I crank it up and down. But I don't know the exact output level that I'm feeding into this circuit. Is it indicated in the manual anywhere? I don't think it does. I think it just says stuff like, you know, keep things turned down as low as you can get away with while doing this. Just one sec here. Looking at the wrong alignment instructions, which won't help. So, set signal generator 455 kilohertz, plus or minus 0.01%, modulated at 30% at 400 hertz. You know what? I cannot modulate this. Adjust top and bottom cores of T1, T2 maximum audio output. Keep signal generator output low, so diode low voltage does not exceed 1.5 during final adjustment. Well, that's interesting. Okay, 1.5. So 1.5. This is full scale here. So we're already over. Let me just crank it down this way. So there we are at 1.5. You see, it's still easy to see dip here. No problem at all. And what are we doing now? We would want to check that that is really 455. You know, I've checked enough. So the interesting thing in doing this test is what were those little chops that were on there when I was feeding this through the antenna, trying to get it all the way to the IF like this. That's kind of interesting. No clue. I just cannot really imagine what would happen there. So again, because I can't assess the signal level output, it's not going to the antenna anyway, so what does it matter? The book doesn't say anything about it. And look at this, I never ever put the ground lead on. but doing all this, maybe you know, it's grounded through this. This is providing the ground. Although you think this would shield things a little differently. Okay, everybody, watch the scope. So it seems to trim down the signal a little bit. Probably because I'm changing the impedance of the circuit into which I'm feeding. If I have only one wire hooked up, then it's not really dragging the impedance down as such. Mind you, there is this ground thing going on between equipment. So maybe this knocks down the signal because I'm activating the capacitance of this cable by doing that. Follow what I'm saying? I do. If I'm the only one following what I'm saying, well, glorious for me. Okay, we're just going to move on to the next thing. The next thing is this will probably be all I'm going to get done today. Next thing is check the crystal oscillator frequency by coupling the oscillator to a frequency meter or to a calibrated crystal oscillator having 0.001% accuracy. and a receiver. Well, I got a way of doing this that will have the same effect basically. So I'm going to get all that set up, and we're going to look at a spectral display upon which we can spot the local oscillator frequency. That's the objective. Okay, so obviously you're seeing my bench down here, and up above you're seeing the spectral display of my SDR radio. There's no input to it. I noticed messing around with this the other day. I have a shorting piece here I'll put right on the input to this radio. I won't spend too much time. There's a short on the antenna, and what is this over here? What is this? So this thing is full of its own little internal signals. Is it popping up here? Look at this thing. There's no signal going into it at all. Let me take this back off. Here. Whoa! Oh, whoa, 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 whoa. Exploding. So onto that I'm going to put a pickup coil, and we're going to sniff around this radio and try to pick up the local oscillator with it. Attach the pickup coil, and a bunch of stuff should show up. On there, some stuff, any stuff, not much stuff. We have a problem. What problem do we have here? Okay, a little bit of a sideshow. On to the sideshow. Here's my SDR radio. It's plugged in. Uh-oh. I'm going to have to restart the radio. Maybe there's something amiss here. Don't do this to me now. Yeah, there's just a zero. Oh no. Did I blow up my little radio? Okay, continuing with the problem with the SDR for a moment. Where are we? We're at 20 M. Oh, we're way up high here. Let's come way down. That's probably the whole deal. Okay, so we're in the radio range here. This is the AM band, this blue bar. There we see lots of stuff on there. You know what? It's just me, as usual. Let me grab the antenna. There. See the jump? Okay, everything is normal. Everything is normal. I'm not normal, but everything else is normal. So the local oscillator is going to be running at the frequency specified by the crystal, 455, probably above the set frequency. So we're on channel 15. Channel 15. Let me just take a peek here quickly. Bear with me. I like the additional sound effects. Channel 15 is, the crystal is running at 26.680. So that's what we want to find on the SDR. 26.680. SDR back, please. So we go to 26. Anybody remember what that number was? Oh, Mr. Short-term memory is just boy. Okay. Well, let's sniff it out. I got the sniffer going here. I'm going to hold this towards the radio and just watch for something. Generally, you'll spot it on the waterfall display. It shows up. Think for a minute. Have we got it on? Maybe I haven't got this tuned up high enough to show. 26. Yeah, really, it's too low. Let's go up higher. Hey, look, the CB band is actually highlighted in this radio. In this, on my SDR. I didn't even know that. Oh, that's great. So, we're tuned to 15, which is roughly here. 455 is only a short ways above. We should see it. We should see it right in that band. Here we go. We're going in. Show me a new line down on the bottom. So, I have to figure out which tube is a local oscillator here. Nothing's happening. it's definitely receiving. Usually this gives a response pretty quick, especially if I can get around the oscillator coils. Even near the wow, just zero, more zero here. Is there something wrong with what's happening? I've got the power on, the radio's working, I can see on the scope where it's picking this up. I mean, it's definitely here. No response yet. Okay, so the local oscillator, is there a coil associated with the local oscillator? What if let's poke around the top here before I start doing that. So get near the tube that's involved with the oscillator. Wow, okay, so this doesn't work every time. Anybody. Okay, so is my brain totally distorted? Am I completely up to lunch on this? Let's go down to another channel here. Lower channel. That would move the local oscillator a short distance on the screen here. I mean, it would hardly make any difference, but I thought I'd better try it. Oh my gosh. Nobody at all wants to come. Okay, so what I'm going to do, I'm going to assume that this pickup coil just isn't going to do the trick for us. That's really where the problem is right now. So jump onto the schematic here. And, okay, so I think the schematic is here. So what we want to look for is where the local oscillator is. It's going to be where a bunch of crystals are. Here they are. Here's a tube called a mixer. Let's zoom in on this part here. So here's all the crystals. That's interesting. They've got channel numbers written in here. Well, maybe not. Maybe those aren't channel numbers. They don't make much sense the way they're going. So the crystal is tickling this grid. Now in this case you don't need a feedback loop to support the oscillation, or I think you do actually, really. You still need, I think you need something making the crystal, here it is here, a Y1, making it oscillate. I think you put it in a circuit that's sensitive to oscillation and give it a little kick, ding, and away it goes. So that would be all this stuff, I would think. All these coils and things. Is there anything adjustable in here? So 27.1. 27.1. What's the deal with that? 27.1. I don't know what this is. It's T3. So it's a can in the RF. Note 2. These, by the way, are voltages. This is 190 volts on receive, 220 volts on transmit, 24K if a resistance measurement's made without power, and you see these numbers appear all over the place here. So you can check back on these things. So it's very good. That's very, very helpful stuff. Down here, oh, here's the notes. Gotta read these notes. BTBM, K, thousands and millions, capacitor charges on resistance. That's a note. Note 2. But it was note 1. Oh, was it note 1? Note 2. Note 2. Capacitor charges on resistance measurements. So that, I mean, that's quite common. You go to make a measurement and you can tell there's a capacitor charging in the background. Use RF choke on meter lead for voltage measurements. Varies with squelch setting. Okay. Note, better read all these. Unless otherwise specified, all resistance values. Tap switches are shown extreme counterclockwise position as viewed from shaft and tap switches. I don't have to worry about that. That's for the you're running I think the taps they'd be talking about are, I don't know. Maybe I don't know. Doesn't matter anyway. Oh, let's take a look at this. Here's this interesting arrangement. So if you look at the top here, tube types and heater connections, and they give two different models: the 242-128 and the 242-127. The 127 is the 6-volt model, and the 28 is the 12-volt model. I have a 12-volt model. So see what they've done? They've taken two, like these two tubes. It's the same tube. They put the heaters in series, 12 volts across. You get 6 on each. Look at this one. Yeah, 12 volts. So 12, 12, 7. 7. So tubes with the number 7 are no longer indicating that they run with 7 volts. That's not what that means. They picked 7 because they didn't want to use 12 or 6. They didn't want to put 12 there because there's something special about these tubes. Something like that's going on. So I think these are both 12 volt tubes. They better be, because they're getting 12 volts. 12. So here's a couple of 6s that are in here. And you see, and look what they've done here with the 12. Look what they've done here. Why they grounded that? Yeah, this is grounded. So they picked this off and fed it this way and this way. What are they doing with that 1287? Would there be 6 volts sitting here? I guess there would be, because you'd have. Look at the way they drew this too. Why didn't they draw it like this, straight across? Why did he loop it up like this? Why didn't he put this right on this corner? What's he trying to say here? So this is a complicated voltage divider, with this being a single element, and then there's 2 more elements in parallel, 3 in parallel. Well, I guess they just figured out that if they hook it up this way, they get the right currents going to the right tubes. I don't know. A lot of these 12 volt tubes have a center tapped heater, and you can actually feed 6 and ground the center and put it in a 6 volt radio, but get 12 volt operation out of it. See down here? This is exactly what they've done down here, I think. What have they done? Power from here into the middle, both sides grounded. So you can throwing 6 volts onto either leg of a 12 volt overall heater. Same thing here. And here they've rewired these that are in series. Now they're no longer in series. I think you can just pop these, change these tubes. No, it can't be the case, because these would remain in series. There must be some wiring changes. That's why there's a different model number. And that's why there's, hello Jim, that's why this chart is right here on the schematic, because there's a difference between these 2 radios. You need to know. Otherwise, all the same up here. Okay. Now, what exactly am I trying to do here that I've totally lost touch with? What are we doing here? Oh my gosh, I totally lost touch. We were looking up here, trying to find a good place to pick up the oscillator signal. So this coil and this coil are the target coils. This coil is close to where these are, and this coil will be close to this tube. It's all going to be close together. So I'm going to look for these 2 coils. Hey, you know what? There's a diagram in here. I can find them that way. Let's do that. It's just a little easier. L3 and L4. Hopefully I can remember that long enough to go over here and look for L3 and L4. There's L3 right here. And L4 I'm looking. Some of these are in boxes and some of them are not. I wonder if the ones that are in boxes are the ones you're supposed to find to adjust. So for instance, L4 would not be in a box, it would just be out here. L2, L6, L5, come on. Hey, don't hide L4 from me, you know. L4's up on top. L4, L, well there's L3 from the top. There's L, so this is the 12dB6. It's not really what we're interested in. We're interested in the, I can't remember. I don't know. Look at that. Is that in my radio? That little sticker? I don't think so. Nope. I don't have that sticker. I left off my radio. I did try poking around these areas. L3. So L3 is a good target. Let's try that. Let's just get poking around. Okay. Here we are. Okay. So L3 is this one here. Make sure there's nothing conductive sticking out because there is right here. Let's go. I've done this spot. Okay, so I'm going to change bands. We'll see if something comes and goes. This is not going well at all. I can hold it still enough. I'm not sure why is it bopping up and down here. Local oscillator is not working because I have, you know what, maybe it's not working because I have the, no, those connections are on the outside, the far side of the IF. They shouldn't, wait a minute. Well, I certainly see a local oscillator now. You know what? I think there's a note in the manual that actually says when you hook up the clip lead I disconnected, when you hook it up, the local oscillator will stop. There it is, though. Down, way down around 26. What is that? 26,550. Oh, I feel some calculations coming on. Let's turn the. Okay, so there's no crystal. No crystal. Another crystal. See this location? Now I'm going to flip between 13 and 15. Channel 13 and 15. The delay is the SDR. So there we are. Okay, that solves that whole mystery of where's the local oscillator. So now we want to try to attempt. Interestingly enough, this seems to be like a. Doesn't seem to be. It's below, isn't it? So we're on channel 5. Channel 5. Let's do some stuff here. Channel 5. Let's do some stuff. Okay, channel 5 should be 26,560 is where we should see it on the SDR. Interesting enough, yeah, it's below. It shows it below. Quite often the local oscillator runs above the target frequency. This one runs below. 26,560. Okay, let's look. Oh yeah, let's get it on there. I'll get it on there and then we'll mark it. If I can use my left hand to blow it up. Okay, let me just. So I would say, I think with a 7 there. Okay, so now I've tuned the SDR radio to the local oscillator. So I can take the local oscillator away and we'll still know where exactly it's still picking stuff up way out here. We'll know. So if we take 26557 and we add 455 to it, oh, these are not easy numbers. Well, let's see. If we add 55, we get 602. 12, carry 1, 612. 55 gives us 612. And then we add another 400. $26. You know, shame on me. I started thinking about something else. Okay. Let me just get a pen here. I can't think of one thing for more than about 30 seconds. I mean, it's like everybody these days, and I can't even find a pen right now. Oh boy. How dumb can you be? Okay, let's try it again with no pen. Yep, a pen, a pencil. Uh-oh, found my pens. Kind of a weird pen, eh? Okay, now because the arithmetic is too much for my head. 26557. We want to subtract away 4. No, we want to add 455 to that. Let's see if we come up with the frequency we're supposed to be tuned to. 455, 2, 1, 0, yeah, 27012. And what's it supposed to be? What's it supposed to be? Oh my gosh, 20, yeah, I'm on channel 15, 27, whoa, 012. Well, this didn't work out at all. Wait a minute, I'm on channel 5. I'm on channel 5. Oh, that's closer. 5. Yeah, there it is. 27015, and I calculated out 27012. And that's easily just with a little bit of errors here. I think I better sweep through this radio with a 27015 signal and see if it really does peak properly. Let's just double check every channel, and then I think this is telling me that this is correct here. One of the difficulties is this radio itself, just as every instrument I use, has accuracy issues, and this is no different. This radio has accuracy issues. Really tough to prove them. You just got a whole pile of instruments. It's all, you know, internally referential arrangement here. The best crystal stuff I've got is actually, you know what? This CB radio is the best. I should be relying on the CB radio itself. Okay. So we're gonna pass through one last pass. This is the end of the receiver check. That's what we can call this. The end has come. The last check. So we want this way up high. And we're gonna, it doesn't have to be a calibrated test. I'm gonna take this from here. Calibrated in the sense of output strength. You know, I've noticed when I watch my videos, often I say things, they're incomplete statements, but the rest of it is in my head. It's not coming out of my mouth because there's no one here, right? So I don't feel the need to explain everything down to the nuts and bolts sometimes. Just kind of spontaneously talking here. So I apologize very much for all the stupid things I say and do in here. Now, I think we're all set. Zippity doo dah. Let's get this out here. Just got too many things to look at. get this microphone out of here too. Okay, we're ready to go here. So we'll put this onto, we'll put the radio onto channel 5, and we'll get this guy up close to 5. 5 is 26 something. Okay, turn up the volume here. Switch it on to antenna. Oh my gosh, what? I don't know what happened. I had the volume. I don't know what happened there. Suddenly it came to life. Okay, but it did come to life, so that's good. Now, we'll just tune the generator till we hear it come in. $26,096. 26,096. So I'll look at the chart here myself. As soon as I figure out what to do with it. 26. 26. Wow, this isn't even on the chart. So this is, you know what? This is almost a million out. So this is an image. So the radio's image rejection. Well, you're seeing it right here. Pretty strong signal though. So let's keep going up, because really this channel is actually at about a megahertz higher. That's perfect. This is definitely the image. Away we go. This would be a whoop. Zooming right past it. There we are. Okay, it's tuned to what? 27,005. 27,005. And I look on the chart. That's channel 4. That's channel 4. Five is 1.5. So you can still hear it. But in fact, hey, you know, this is interesting. The fact it's down here. So crystal of 5 producing, well, I don't think this qualifies as being okay. Let's do the other channels. They're all low a bit, then there's probably an adjustment. So this would be channel 13. So we'll go up and make it. Oh. I would say that that's 27,110. And I don't think that's anything. 27. It's either 105 or 115. It can't be 110. 105. Oops. That would be about there. And it's definitely not the 15. 27,115 is 13. 13, and we're actually tuned to 14 here. This isn't even making it up there. Because 14, wow, how did I miss all this? 27,125. So the crystal, so this is, wow, okay, so this is bad news. So, you know, maybe the crystals have drifted off. We should be hearing 14. Okay, we'll go up to 15 now. 15 sounds like 14, doesn't it? So 15 is supposed to be 135. So this very much looks like 14. Let's just fiddle around over the 14 thing for a sec. Very much so. So we do have a 14 in here, in effect. But the actual 15, I think, is a 145, 135. This should be. So again, you can hear it a bit. See, this is what would really be a trouble. Now, these are channeled devices. So you tune it to this channel, you can't fine tune it. There's no fine tuning. So this is what you get, and you think, that must be it. Meanwhile, the real signals are sitting down here. If you kind of know what I mean. That's not quite the right way to say it, but I think you know what I mean. So very tricky to figure out who's on and who's off with these channelized. Remember the old TD sets? They had fine tuning for every channel, because there's no way you can channelize this stuff and not require some fine tuning to compensate. There's no fine tuning in here. Well, there might be some kind of adjustment I can make. There's no fine tuning on the front panel. So either the crystals are just off now, and they are what they are, or there's some kind of adjustment. Well, I'm going to look in the manual and see. But this is a bit of a finding here. Somehow I missed it earlier on. Another thing we can do is we can warp the IF frequency. We can push it off 455 to compensate for the crystals being off, if that's the case. If the crystals really are off. Look at this big capacitor right up here. What's that tuning? Tuning something. And there are adjustments. The crystals are down here. I think you can push a crystal frequency, its vibration, a little bit this way and that way, but we're talking like 0.001% variation. I can't imagine you can vary it between channels, but then that's just my imagination, right? Okay, let me stop for a bit and check out the manual here. Okay, this is an emergency recording. I was just sitting here getting ready, and the radio just went dead. So it was making a nice tone from the signal generator and just dead. Ooh. Don't like that at all. Okay, chances are antenna wires. Okay, I'm touching the back of the antenna. I would think that would make a. It's sounding like something has come open. Oh my gosh! I'm not counting on this. Okay, the volume's got to be up a little bit here. So if it comes to light, which I hope it does. Probably be one of the later stage tubes. Oh, I heard it. Okay, appeared to be just a tube contact. Well, it's a couple times this radio has done that. It's never caused a problem until just now. So I have not pulled the tubes out of this. I have not put them through the tester or anything. So bad tube contact's possible. Okay, so emergency's over. Emergency's over. Everybody, get back to work. Okay, so there is a coil that has a slug you can adjust that changes the local oscillator frequency. How far? You know what, I don't know. It's this big coil here. Which one? Should I get this right? This one here. So let's monitor the output level, the sound level on here, and then we'll just try to migrate the local oscillator frequency to where it should be. Once we get this going. The frequency is supposed to be, once again, we're on channel 15. 27135 is where we should get to here. It's pounding too high of a signal into the radio right now, but 27126. What's the problem? 27135 is where we want to go. So we'll head there. I'm there already. You can still hear it, which is great. Oh, that's great. Okay, I can probably adjust this in. Wait a minute now. This is one adjustment for all of them. Well, that's what it is. One adjustment for all of them. So I know, I may know. Okay, here we go. What am I watching now? I'm watching this level. Going up. Going down. What's that mean? That's it? 135. No way. Did it change at all? Because that's what it is. It's still 126. I hope I'm turning the right control. Famous last words. I'm going to turn it back towards where it was. Watching this meter. Going down. Okay, what's that mean? Does that mean I'm moving it higher or lower? Let's turn this higher a little bit. Down. So I'm turning it lower. Oh, you can't even tell. You know what? It's just varying the strength, maybe. Turn it back up. Up, up, up. Keep going. Oh, not quite. Pretty close to the end of the road here. This is not going anywhere. Oh my gosh, maybe I've done the wrong thing. Or I really, you can't move these crystal frequencies very far. This is a tiny percentage change really, because we're up at 27 megahertz. It's a tiny percentage to move this local oscillator. Why can't I do it? Because I've been stupid and picked the wrong thing? Is that what I did? Oh no. Join me on this painful examination here. So starting with 15. Are we on 15? The way I remember it was 15. You know, maybe I got these numbers wrong yesterday when I looked at the chips. Look at them again. Let's look at them again. Let's just make sure I'm not making that's my stupid mistake. Maybe that's my dumb mistake. Let me get the close-up camera going here. Let us go see. So, looking at the receive side of this, well, it says receive 15 right on it, and right above it, channel 13T, channel 13R. How can I possibly be making a mistake here? And this one, channel 5, receive and transmit. There's no chance anybody pulled these out and flipped them around wrong or did anything like that. Look at the channel 13 is too red to 2 red paint marks on it, but the others don't. What happens if we wiggle those guys? Okay, so I'm wiggling the crystal. You wouldn't know it. So maybe what I should do, you know, I don't care that this is on 15. I want it on something. I don't care if it's 15. It can be 14. It can be anything. What do I care? So really, what I should be doing is identifying the true channel reception and then tuning it up to get to where it wants to go anyway. Why am I fighting? Why am I fighting? What am I fighting for? Because I think if it's receiving channel 14 when it should be 15, that there's a big alignment issue that I can sort out, and that's what I'm thinking, but maybe not. You know, the crystals have drifted after all these years. Do they do that? I know the crystals that are used in cartridges, record player cartridges, certainly age. Some terribly. Age just terribly. Is that what happens with these crystals? I don't know. Lots of things to look into. So I'm gonna leave it at this point, because I don't have to know exactly what channels these are on. I kind of have the impression anyway, one channel lower than what they say. And we'll just leave it like that for now, because we have the whole transmitter side of this thing. I still have more to do on the receiver, I think. Hey, maybe if I do more on the receiver, this problem will correct itself. How do you like that? But I think I'm done for now. I think I'm done for now. Thanks for watching. See you on the next video.